Hi folks, Mr. Long here. I'm doing a screencast to finish up a question on working with surface area and volume. So we worked with a couple of cylinders that had a volume of 452.39 centimeters cubed. What we want to do is now take a look at putting that same amount of volume into a cube and then into a sphere and see how much surface area we get out of it. Okay, so we're going to do it with a box, a cube, and then a sphere. And they have some similarities, right? Because all the lengths are the same in a cube, and then a surface area, or rather a sphere, has just a radius in every direction, right? So we know, the only thing we know about these shapes is that the volume. We know how much space is inside it. We don't know anything else. So what dimensions are there on these shapes? Okay, what dimensions are there? Well, there is a length, and a length on a cube. And then there's only a radius on a sphere. So actually, there's only a length on a cube as well. So we know that the volume is length times length times length. The volume is length cubed. The formula for volume of a sphere is 4 pi r cubed over 3. So those are the volume formulas. We also know that that's the volume. So if I look at this, then I look at this formula. I know the volume, I don't know the length. I know the volume, I don't know the radius. So in each of those, I have one unknown. Okay, I have one unknown. And if I can get the radius and I can get the length, then I can get the surface area. Okay, so let's take a look at it for the cube. So I know the volume of that is 452.39, and that means that 452.39 equals L cubed. Now that's a pretty straightforward one to solve. Just take the cube root. To undo that, we do the cube root of both sides, and L works out to 7.68 centimeters. That's the length. So if you look at a cube, all of the faces are the same. That's length by length, so that makes that L squared. This is length by length, that makes that L squared. This is length by length there, and that makes that L squared. So in fact, you've got an L squared on the top, an L squared on the front, and an L squared on the side. So it looks like there's only 3 L squared, but of course there's a top and a bottom, a front and a back, and a left and a right. So altogether, there are 6 faces, and each face has an area of L squared. So the area is 6 L squares. Well, I already know what L is. It's 7.68 centimeters. So that means the area is 6 times 7.68 centimeters squared. The area is then 353.58 centimeters squared. Okay, and you can work through this if you like with your calculators. Actually, you should do that. You should have your calculator in your hand as we're working through this, and you can pause and rewind and things like that. So again, this is a case where if you didn't understand something I did there, just rewind a bit, watch it again. Now let's get the surface area of that sphere. So we know that the volume of that sphere is 452.39, and we know that the volume is worth that. So 452.39 equals 4 pi r cubed over 3. So I need to solve that equation. Now that's not quite as easy as the cube, so let's maybe look for this one at bed mass and inverse. So I know the first thing that would happen would be that cubing if I had a number in there for r. So the first thing would be to cube. Then I would multiply by 4 pi, and I would divide by 3. So what's the inverse of that? Multiply by 3, divide by 4 pi, and take the cube root. Okay, opposite order, opposite operation for inverse. All of those things apply to 452.39. So I would do these ones together in terms of knowing what to do. You can do the multiply and the divide in one step. So you'd have 452.39. I would multiply that by 3 and then divide that by 4 pi. And I would put that into your calculator just like that. I think if you do that, you're going to find an answer of 216, I believe. And once you get that, then you have to cube root, and that's going to work out to 4.76 centimeters. Okay, so that's the radius. So following that, we need to figure out the area. The area is equal to 4 pi r squared. That's the formula for the area of a sphere. So we just substitute that radius in. 4 pi, 4.76 centimeters squared. And notice that you can see really clearly in things like cubes and spheres that if you're doing area, you're squaring, right? Because there's two dimensions to area, length and width, or radius and radius. Whereas in volume, it's always cubed because there's three dimension, length, width, and height, for example. Or radius, radius, and radius. Okay, so if I put that into the calculator then, the area is 284.99 centimeters squared. So, finally, the last thing is, oh, by the way, look at that. The sphere is more efficient than the cube, right? The sphere is more efficient than the cube. So that's the sphere, and that's the cube. Okay. So overall, the best cylinder, that doesn't look very good, does it? The best cylinder, CYLBEST, it had an area of 326.23 centimeters squared. The cube had an area of 353.58 centimeters squared. And the sphere had an area of 285 centimeters squared. So the sphere then is the most efficient shape. Okay, it has the least area for a fixed volume. Remember that all of these shapes had the same volume. So they all would hold the same amount of fluid that you might drink, or chocolates, or if it was a present, you can say that they all three of those shapes hold the same amount, but the sphere is actually the most efficient shape. It's number 1. The cylinder is number 2, and number 3 is the cube. And if you remember, the really wide cylinder that looked like this, it had a height of 1 and a radius of 12. The surface area for it was 980 centimeters squared. So it's not a very efficient shape at all. Again, the closer you get to a sphere, the better the shape is. And a circular shape, of course, has less surface area than something with straight edges, because you get rid of all those corners. Okay, so hopefully that helps. And again, pause, rewind, go over things again. Have a good night, everybody.